All right, so welcome back. We are going to look today or talk today a little bit about game interfaces. Now, game interfaces are there to provide a couple of very specific uh, pieces of feedback, so to speak. Um, the first thing, the first feedback that the game is supposed to do is moment-to-moment feedback, then progress, moment-to-moment feedback, instructions, progress, control, and then there's a couple of secondary things. Um, Now, the moment-to-moment feedback are the very uh, straightforward things that you expect. They are the character running through the world. They are, oh, I got hit by a baddie. Boom. I've taken damage. This is a thing that I don't want. They're there to provide those instantaneous things. So you get the little like +1 floating above the character's head. That's a piece of moment-to-moment feedback that they need to know. They just swung their sword. They're having a change in the world. The UI's or the game interface's goal is to make it very clear what that change that they caused to happen in the world, what that was. The second step, instructions. So you have to let the player know how to play the game, how to interact with the game, what buttons do what. And just as a simple example, when you walk up to almost anyone in a modern RPG or other game where you can interact with a character, there will be a little bubble that pops up above them with the X button on it, or the Enter button, or what have you. That's a little subtle piece of feedback that here's this thing within the world that you can interact with, and in fact, you kind of have to survive. Um, if you have a boulder that you can push or pull, or something along those lines, usually in the interface you'll have something that pops up. Um, there is generally a strip of information along a lot of these windows that pops up that will have information on those strips that will have button information. I find that people very rarely look at those, so they're less good for moment-to-moment feedback of, oh, you walked up to a door, you can interact with this door now, as said by this thing in the small corner of the screen. But when it comes to global things, if someone's confused, if someone's lost, those help bars, as they're called, can be helpful for providing that feedback, especially if they're not there all the time and they only appear when there's a good need for it. So try to keep those out of the way. Other instructions include goals. Hey, that's a character over there. They're blinking bright red, so therefore, there's someone that you should probably attack or be worried about. There's there's a flag waving down off in the side, so that's a piece of information or instruction to, oh, there's a flag over there, therefore that's my goal. Um, Racing games, obviously, you have the movement of the track lighting that's all drawing you towards your goal, and of course challenges. So if you come up to um, if you come up to a cliff and you see little arrows that say jump down, that's a very simple piece of information that says that this is a jumping challenge, or um, excuse me, or in a driving game where you might have arrows pointing you in the directions that you need to go. Simple things like that. That's basically calling out to the player what the challenges are um, by using the user interface. Now, there are other nice pieces about an interface that don't necessarily tie in as directly to the world. One of those is your progress monitoring. How are you doing overall? Um, I'll see if I can get a copy of the program that I'm working on right now. But this is Core 5, so this is a language instruction program, and you can kind of see that there's a strip here that says how the player is doing, or in this case the student is doing, through a unit. Um, this is the only thing, or basically the thing that tells them how well they're doing overall and how far they are through something. Um, so that's sort of their success. There's also duration feedback. How long has this been going on? You've been doing this for 20 minutes. You can kind of expect to do this for 5 minutes more. Those are really important to the player. Less so about how long you have been doing it, more so about how long they have left. That's really the thing that people care about, and whether or not your strategies are working. So if you're trying to, if you've opened up a thing in SimCity and you're trying to get your pollution level down, how can the player know in a really straightforward and easy way, oh, their pollution's gone down, oh, their pollution's gone up. Why has their pollution gone up? Well, there are these regions in the city where the pollution is really big that maybe they didn't focus their strategy on, so they need to refocus their strategy on these particular hot zones. That sort of thing. That's up to the user interface to try to provide feedback on. The user interface is also generally how the player gets information about their controls. We talked very briefly about this in class once, but the goal of your controls in general should be that you want them to be as discoverable as possible, that the player can figure out everything that they're doing by just clicking every button on the controller, tapping everything on a touch screen, which, by the way, players will tap everything on a touch screen. It's strangely obsessive. They don't click on everything in a PC game, but they do tap everything in a touchscreen game. It's very strange. And then, of course, in a PC game, what those interactions are, those get hidden a lot by the keyboard, which is why I generally try not to use the keyboard for much in PC-based games, though I have not developed too many of those. So you want to focus in on how the interface interacts with the controller. So if they're trying to, call up a specific menu, and this menu is a radial menu. If it's a circle, if, say, they press a right trigger and a radial menu appears on their screen, they're going to know that they have to move the right thumbstick to interact with that menu. So you want those kind of things to be both discoverable, press a button and menu comes up, and intuitive for how it maps to the physical controller. And then there's the secondary goals of the user interface, which are, immersion and atmosphere. You want to make the interface set the tone for the game. You want it to set the style. As one of my favorite UI artists has said, in your user interface, you want the UI visuals to set the tone, to be beautiful, and immediately get out of the way. Like, you want it to be the minimal possible to set the scene for, we're in a sleek, very modern, very Tron style interface, or we're in a very old 1930s wooden Industrial Revolution kind of thing. I know that the Industrial Revolution was before the 1930s, but you want to set those tones and then get out of the way as fast as possible. A lot of the times you want your interface to draw only attention to itself when it needs to be, and you want it to get out of the way as much as possible during the rest of the time. So if you take damage, you want that bar to turn red and shrink, and then turn back to whatever color it was and fade into the background so that the player can see it if they're looking for it, but they don't have it pressing into their field of view and it's not distracting them from paying attention to the main game area. Now, when you're trying to create one of these, there's a couple of considerations to put in. Functionality, does it work? Can the player actually do all of the things with the interface that they need to do? And that's bigger than you would think. Again, the example that I was giving in class was having to aim on the thumbsticks, oh yes, and press buttons on the faces. So that's an example where you just can't do those two things simultaneously. There was a game that I was playing earlier, I can't remember the name of it, but it had you running around with the left thumbstick, which is mirrored on your screen, but with the left thumbstick, and then you had to press the left D-pad to do certain actions, which means you had to take your thumb and fingers off the other side and go over to the D-pad over here and then go back. It was a really bad design, but of course they had certain limitations of the amount of buttons that they needed, So they just made that compromise where this is going to be an awkward interaction. It functionally doesn't quite work, but but they had to do it. Usability. Can people use it? Do people pick it up and understand exactly what's going on? Um, the shoulder buttons are generally less discoverable than the face buttons, which is why the face buttons are the go-to for a lot of these things. The X button, or whatever is the face button that is in the on the right side of the buttons, there's one at the bottom. That is the go-to in the US. Strangely enough, in Japan, the go-to is the top of those things. On the PlayStation, that is a triangle versus an X, but that does depend on which platform you're on. But universally, strangely enough, it is the top button is going forward in Japan and the bottom button is going forward in the US. We've mostly standardized around the bottom button being the go-to worldwide at this point, but you'll still see that confusion cropping up. Discoverability. When you're trying to create it, can people discover how it works? When you press a button, does it do a thing? Even if it requires a combo of buttons, can they figure out what that combo is? So you want to make sure that hammering away at everything makes itself self-explanatory, even if it's something like your characters, like whiffing a grab for a throw that they can't do. They need to whiff that grab, not just for aesthetic purposes, but so that the player knows that button does anything at all when they're just pressing all of the buttons trying to make it work. You want to consider aesthetics, which is, is it beautiful, is it functional, is it fun? And of course, accessibility of your user interface in general. Now, do you have audio and visual cues? When someone presses a button, do they get a sound? If there's a warning, do they get a sound rather than just the light? Some people hear better than they see, and it's helpful for them to have an interface with a lot of audio components, especially for warnings. Nearsightedness. Some people need a bigger interface than others, especially if you're still supporting smaller screens or older televisions. I remember in the early Xbox days, Dead Rising came out, and it was clearly an HDTV-based game, but the Xbox was still supporting old televisions. And on the old televisions, the text was literally unreadable. It was small enough that it was non-viable. You couldn't read it. There were just not enough pixels to pull it off. So, is your interface large enough that people can read it? Ideally, your target, but of course, there's going to be people who are relatively nearsighted and are playing your game without glasses, or who are a little bit older, or who are a little bit farther back, or who are watching it on a bad projection system. A lot of people bought TV projectors about 10 years ago when they started becoming really affordable for the mass market, and now they're all blurry and don't project as well as they used to. And your game's going to be on a bunch of those. Is it still readable and playable under those circumstances? There's color blindness, and there's actually a couple of really great apps on your phone which will allow you to just translate between the different types of color blindness that a person can have. So you can see what it looks like when someone is red-green colorblind, or when someone has one of the more obscure forms of color blindness, how everything that goes into the camera looks to one of those people, which is fascinating and really helpful. So make sure that you run that through one of your through the interface in your games. Now, the nice thing about color blindness, or working with color blindness, is that it is not intensity blindness. So if you have things that you need to, or texture blindness, so if you have things that you need to call out to your player, buttons and things that rely on color, you can make the red a darker red and your green a lighter shade of green, and so those two intensities can be the thing that red-green colorblind people cue off of. You can have textures to them. Maybe the red is a horizontal hash and the green is a cross hatch at a diagonal. Those sorts of things, or change the shape. Generally, those are the things that you play with when you're creating an interface: the outline shape, the texture on it, and the color. Oh, and the intensity. Um, you want to make sure that that there's coordination and timing. That if your game is all about coordination, then that's great, and you want to focus in on that. If your game is all about strategy, then you want to make sure your interface has nothing to do with coordination. You want to make sure that you have very little tightly timed button presses or very little things where the player has a couple of seconds to make a response on a menu, unless that's the core to what you're trying to do, because a lot of people just don't do that well with that kind of gameplay, that aren't looking out for that. Either they didn't grow up with tightly timed interface elements, they don't necessarily just like that kind of thing, and they seek out games that don't cater to that. And so if you're creating a game that's kind of not catering to tight timing, make sure that your game really doesn't. That your game stays really clear of those kinds of things. The opposite is kind of true, and honestly, as a broad design philosophy, you want to be what you are. You want your game to focus in on the aspects of gameplay that's, so to speak, promised on the box. Um, I worked on a real-time strategy game, Empire's Dawn of the Modern World. One of the scenario designers at the time was Ben Schneider, whom I love. And if Ben's watching this video, you do great work. But at the time, one of the things that came out of the single-player scenario was, hey, let's create a puzzle type game, and because I couldn't quite figure out a culmination ending to this storylines. So it ended with this puzzle game where you're trying to chase someone down through a series of locking doors. It had nothing to do with the fundamental gameplay of a real-time strategy game, and people would play through and they would have a good time with the real-time strategy part, and they would get to this other part where it was puzzle gameplay of a style that they were not at all expecting, weren't looking for. It wasn't bad. It wasn't a bad puzzle. I actually rather liked the solution that they came up with, but it was a little bit like trying to buy a cake and getting a cake and then a big chunk of ice cream. It was really good ice cream, but they bought a cake and they were coming for a cake. Or if not ice cream, then sushi. Like, it was very different. They bought a cake. They've been eating cake up until this point, and suddenly sushi, fish. Um, so you want to stay focused in on what it is that your game is both trying to be, has been up to this point. Focus in on what makes it great, and avoid the other kinds of elements that maybe not necessarily on the box, so to speak, that people didn't necessarily pick up the game for. And in this case, for a user interface, that's coordination and timing elements. Either be very timing based throughout the whole thing, or don't. Give the player a lot of options there. Subtitles. Subtitles are actually kind of an important thing for a lot of people, especially if your players are non-native English speakers. You're going to want to put subtitles in there for them. Or if they're playing in an apartment and they just can't happen to have the volume turned up very loud because their roommates are sleeping, if they're trying to play without their kids realizing that they're awake or waking up the baby, those kinds of things. There's a lot of valid reasons to play without the audio on, or otherwise with needing a little dialogue help. So I definitely recommend supporting subtitles. Now, a couple of caveats. A big one for interfaces is information overload. Now, information overload comes from when you're trying to see too much on screen at once, when you're trying to process too much, when there's just too many buttons and pieces of feedback in areas. And that means that there's no hierarchy. Now, I'm going to call it out here. In general, we can make sense of 7 things at a time. Max, 5 to 7. You'll hear that number come up a lot. And that can be different regions. excuse me for the cough. You can subdivide a thing into multiple regions, like, okay, this is your file browser, this is your video editing timeline, this is your top bar. And you'll come out with about 7 on a screen, and then maybe you'll have some sub pieces of information within there. So if you have this is all of your feedback bars about the game, that can be one of your major 7 interface components. These are your feedback bars on how you're doing. And then you can at most have 7, ideally 5 bars coming down saying how you're doing in each of these different types of whatever it is that you're talking about. Maybe diplomacy and food supply and how much your people love you and how much arts and sciences you're developing, whatever it is. Your progress bars or your current state bars, you can have 5 to 7 of them. Any more, and no one has any idea what's going on. You can give the player the opportunity to delve in a little bit deeper. Click in, go in, get a little more information. Very few of your players will ever actually do that. So just try to keep that information overload to a minimum. Really, your users will always want less information than you as an advanced player will. Or I should say your beginning users will always want less information than you as an advanced developer will. But there's also the problem of information underload. If you're not necessarily telling the player everything that they need to know to understand your system. This is less important in a Mario game. This is more important in like Civilization V, where suddenly your peasants are rebelling because they don't have enough religion in their world. So you just haven't funded it enough, and you haven't been told on the main screen that this is a thing that could necessarily happen. Information underload, they're feeling sideswiped by this. That's kind of a terrible experience to have happen. Now, let me grab a controller because I want to show you a couple of things about gameplay. Let me just reach over here. So let's consider this a controller. This actually might be an example of information overload. This is a Shuttle Pro 2. This is a thing that gets used for video editing. But for sake of the moment, let's call this a video game controller because they change all the time anyway. Now, there's 2 major types of players that you will get in your video games when interacting with the controller like this, a standard video game controller. They're generally called precise or sloppy. And that's not a judgment call on the people, that's just a general style of controller interaction. For the record, I am a generally sloppy player, which means I rock my buttons, as a lot of players do. So what happens is, trying to get it here, if a player has to hit 2 buttons at once, remember the 2 are precise or sloppy, say it's these 2. A precise player will take 2 fingers and will do that. A sloppy player will take a thumb and will rock it over onto the other button. And this is important because a thumb player can now interact with a couple of these edges in a way that makes... You know what, hold on a second, let me grab another controller. Alright, so we have a more standard Logitech controller. Let me just so I can demonstrate a little bit better. You can see here that a precise player, when pressing 2 buttons, would hit these 2, or these, or these. So there's any combination of button presses is actually available to the precise player more or less, though you'll notice that they have to take their fingers off of the top shoulder buttons in order to do that. A sloppy player that rocks can rock generally to the buttons that are right next to them, with the thumb, though playing this backwards for sake of the video is difficult. But going diagonally and just hitting the diagonals is actually very difficult, You can't really make that cross shape with your thumb very easily. But those players can actually keep their fingers on the top set of buttons as they do that. So they can go, they can rock and hit some of these buttons in different ways and still interact with the top triggers. Your precise players cannot do that, only the sloppy players. Now similarly, your sloppy players technically will do D-pad movements that rotate around more. This is your traditional Street Fighter movement, down, around, and forward. Your precise players will tend to do down, left. So they will remove their fingers from the middle of the pad and go into the direction that they want, whereas your sloppy players will tend to roll into the direction. This can be a big problem. The Xbox 360 controller did not take those people into account and would tend to get stuck on the diagonals. This is one of the reasons why the Xbox controller was considered to have considered one of the worst D-pads of all time, was because that you would get stuck in these situations where it would inherently press down when you didn't mean to, because of the rolling fingers. I remember when I was working at Harmonix, and Microsoft had asked us, oh, what is it that you want out of a new controller from us? And we all said, hands down, fix the D-pad. They never did. And so that gets into other aspects of precise versus sloppy. Now, touchscreens are almost entirely inherently sloppy, whereas mice are almost entirely inherently precise. So a menu, we had a menu in Tinkerbox that you could click to select or drag to move it, to scroll it. Kind of a pretty standard interaction. And in most, we got it back from the engineer. The engineer said, here, try it out, it works great. We actually could not tap to select anything on that menu. We'd send it back to the engineer. The engineer was like, no, let me show you. And he would click, and he would drag, and he'd click, and he'd select. And then he'd send it back to us, and we'd put it on our touch screens, and we'd tap to select, and we couldn't get it to work. And what was happening was that when you press in on something on a touch screen, your finger inherently distorts just a little bit. So they were moving their finger down without intending to, just based on how touchscreens work. So we had to actually make that a sloppy interaction and consider a small amount of offset to be, not an offset at all. Mice were simple. Mice generally stay in place until you move them. So when people were clicking on that, there was no registered offset, whereas the act of clicking on a touchscreen inherently moves it. Now there are a couple of rules for improving the feel of a game interface. One of the basic rules is that you want to make sure that your lag is within 50 milliseconds, and it's better to have 20 milliseconds. And that means basically a frame. Like the player presses a button, the player does something. A frame later, there's a big visual change on screen that shows. And that kind of gets to the second rule of, and that gets to the second rule, that you want to move on inputs rather than on physics. So a lot of times what you'll see is a character moving in a really unrealistic way in video games. And you'll say, oh, okay, well, I'm looking at, say, Batman having a fight. And instead of like having, if you've taken your animation classes, instead of having like an antic that he gets ready to move and then he dashes in, for video game purposes, you want to cut out all of that antic. You want to cut out all of the beginning part of like hunkering down and putting your feet in and getting ready to go and accelerating and then going. You want to cut all of that out of the player so that when the player presses forward, the character snaps forward. That there's a big visual interaction change the moment the input is put in. Otherwise you get interactions like the old Tomb Raider, where you would press a button and then you'd press the jump button and then Lara Croft would wait until her right foot was down on the ground in a running pose, and then she would jump off of that right foot. It was actually really difficult to control. It was like queuing up moves ahead of time, which is what really happens. You don't necessarily decide, oh, I'm going to jump out of my chair, and then suddenly immediately like dash to the side. What actually happens is your body changes weight, you put yourself down, and then you go. So that doesn't feel good though, because by the time the player has already moved their thumb, they've already done all of those steps emotionally. They've already decided what's best, they've already gotten themselves sort of positioned, and then they just want to go. They're already ready. Having a second layer of that prep, while realistic, actually doesn't feel very good. So you want to make sure that those movements are big and happen immediately upon pressing of the stick, rather than with any sort of like physics lag for, oh, we're going to accelerate. No, just go. Oh, we're going to like hunker down and place our feet and get ready to go. No, just go. You want, in general, to have, whenever the player presses down, you want to have a big visual pop. If it's say a button on the screen, you want to have a big visual pop that goes on with that when they press down, and when they release, then you generally want the action to happen. You want to make it really clear that you're responding on the down to some degree, and there's a sound associated with it, and there's a visual change associated with it. You don't always want to go at that point. You don't always want to trigger whatever it is that the button triggers when they press down. You generally want to do that on a release. That's because of drags. That's because of secondary button presses. There's just winds up being a lot of interface considerations around doing things on down, especially with touchscreens now, that you kind of have to do it on up. But you still need to have that response on down to make it feel so much faster than it otherwise could be. Because if you press down and up, and that interaction takes 200 milliseconds based on click, 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 if you're going down, if you do a visual and audio response on the down, then suddenly you have a response that's 200 milliseconds faster. And so instead of feeling like the game responded in 220 milliseconds, now it's feeling like it's responding in 20 milliseconds, even though that's just to acknowledge that you clicked and then it's going. But that lag can be a really big change in feel. So you're going to spend a lot of time, if you do become UI artists or UI designers, trying to find ways to make that feel super responsive on the down while actually responding on the up. And then of course there's just a last fundamental thing of go with screen directionality. Whatever it is that is on the screen, if the player presses up, go up in the screen. If they're pressing down, go down in the screen. Follow screen directionality, not character directionality. If you follow character directionality, it feels like you're steering a bus, really. The player is not generally interested in how their character on screen is facing, other than the general purient interest of it's over there. But when they're giving directions, they generally are giving directions in screen space. So, left, right, up, down in the screen rather than in the character's interface. Working on NCAA basketball, we had one horrible example of this where the characters used to be, they were trying to transition between the two. The characters used to be based on facing, or move based on facing. We were trying to transition to based on absolute direction, but we couldn't rewrite all of the code. So if the player pressed left, and that's not the way the character was facing, they would generally run whichever way they were facing and turn and eventually get left. This was a problem if there was someone blocking them, if there was another character in the game that was blocking them. So if they, say, pressed left in this circumstance, they would hit this guy here. But how they would hit this guy is that they would start going up and start turning, and then they hit this guy. And now these both run vertically. So now you have a situation where going left, they try to go left, and by trying to go left, it starts going up and rotating, and now it can't rotate, and now it's just going up. And that's the thing that you actually find a lot of in some of these games that are doing rotational-based positioning, where you tell it to, turn and go some direction, and it can't turn for some reason, and now it feels broken from the player's perspective because it's not going in the direction that they want it to. So again, break physics. Don't steer like a car. Try not to have a situation where the player has to go forward in order to go left or backwards, which was always the weird one. The fun one for this circumstance was like down and to the left, where you'd wind up going up because the character would run forward and try to rotate down. So down, boom, up. That was the one we got the most complaints about with this situation. But try to be absolute in your positioning. Go with the screen coordinates with your directions. Yeah, there's a couple of other interface things, but I'll bring those up at a later class. And good luck with your projects.